In this video, we're going to look at topic 65, example 1, where we model with a piecewise defined function. So Alani has a summer job as a lifeguard. She makes $8 an hour for up to 40 hours each week, and if she works more than 40 hours, she makes 1.5 times her hourly pay, or $12 an hour, for each hour over 40 hours. How can you make a graph and write a function that shows Alani's weekly earnings based on the number of hours she worked? All right, so to draw the graph in this case, we would need to fill out the chart. We're just picking some hours worked, 20, 25, 30, just to give us some points that we can graph. So if we know that she makes $8 an hour, to figure out the pay, we could do hours times that $8 for up to the point of 40. So somewhere here, the rate is going to change. So 20 times 8, that would be 160. So I'm just going to fill out the rest of this. 25 would be 200, 240, 280, 320. Now the rate would change after 45. How you figured out, you would be able to do that. You'd have to do some work, and we'll get into the equation in a minute. But the idea with this video and this example is we're just trying to understand what a piecewise function is. So don't worry too much right now about how these numbers are being calculated. Again, you could do it, you can figure it out by hand, you can use a calculator, whatever it is, but we're worried more about piecewise defined functions. So once we have some of the chart filled out, we now have a set of coordinate points that we can graph. So 20, 160 would be somewhere around here. So this isn't going to be perfect, right, because we're drawing this by hand. 25 would be at 200. 30 would be 240. 35 would be 280. So somewhere around here. 40 would be 320. All right, and I'm actually going to change colors because we're talking about the overtime rate now, anything over 40 hours. 45 goes up to 380, so that would be, we'll say right there. 50 is at 440, again, trying to be as accurate as possible, and 55 is right at 500. So if we were to connect our dots here, we have something that looks like that, and we would have something that looks like that. All right, as accurate as we need to be for now, but notice that when you hit that 40-hour mark, your slope, your graph or your function starts to increase at a faster rate because now we're working at our overtime pay, right? If we were to stick with that $8 an hour, your pay, or the pay here, would look something like this, right? It would keep going, but it wouldn't increase as at nearly fast of a rate. So let's get rid of this so that we don't confuse ourselves. But just keep in mind, and it's noted here, notice that the graph contains two linear segments with a slope that changes slightly at x equals 40, right? That's where our pay starts to change based on the hours. That's our overtime rate. A function that has different rules for different parts of its domain is called a piecewise defined function. All right, this is what we're looking at, piecewise defined functions. That's what we care about here. And all it is that within a function, there's different rules for different parts. So in this case, from 0 to 40 hours, we had one rule that we followed. That was the $8 an hour. And then from past 40 up to whatever amount of overtime hours we work, there's going to be a different rule to determine that, that function or how much pay we've made. And the way you show that is we're going to say the function of x, so we're talking about pay, so I'm just going to use the letter p, is equal to, and a piecewise defined function has parts to it. What you do, so you'd have like one part here and one part here, and then you would list the domains of each of those parts so that you say, this is where it applies. The first part of our graph, we're just, Lonnie, I believe, right? Lonnie is being paid $8 an hour. So to figure out her pay, it's simple. It's just 8 times x, x being the number of hours that she worked. And that applies for anything from 0 hours all the way up to 40 hours. We're including 0 and 40 because at 40, she's still getting paid $8 an hour. Her overtime doesn't kick in until she's past 40 hours. And she technically can work 0 hours, right? She wouldn't be paid, but she can work 0 hours. So we would include that with the less than or equal symbol. Now, that applies to this part of the graph right here. Right, so this piece would apply there, or from 0 to 40, that being your domain. Now what's going to happen past that, and I'm just going to write the equation. If you want to try and figure it out how I came up with this equation, feel free to. You can do some work kind of, off on your own. But the idea is that this second part of the graph, that red linear part, the function is going to be 12x minus 160. And again, there's some work going on behind the scenes where if you want to try and figure out where that function comes from, feel free. I'm just concerned with what a piecewise defined function is in this problem, so that's what I'm going to focus on. And that is going to apply to any x value greater than 40. Now, there will be a realistic limit, right? I mean, she can't work 700 hours in a week. But for the purposes of this, we're just going to say x is greater than 40. We're not going to put a cap on the amount of hours that she worked. We're just going to figure this out. And that's that part. So that would be the red part of our linear function. And that would apply from 40, or right after 40, going up in terms of the domain. That's where the x is greater than 40. So this is 0 is less than or equal to x is less than or equal to 40. And then this piece here is where x is greater than 40. All right, we're not going to label the chart that way, so I'm not going to leave that there. But the idea is we're trying to figure out what a piecewise defined function is. And it shows that there's different rules for different parts of our function based on what kind of domain we fall into. And again, in this case would be 0 to 40 or greater than 40. But that's it for this one. We just wanted to show that different rules for different parts means it's a piecewise defined function.